Page 22, number 108. What is the center and radius of the circle equation presented there? Center and radius are pretty easy to find when your circle equation is in standard form. Circle equations should look like this. X minus h squared plus y minus k squared equals the length of the radius squared. With your center at hk and your radius is r. Looking at the circle equation, what you want to do to find your center is you want to grab the two numbers that are in the parentheses with x and y. And what you want to do is you want to flip their sign. The center is always the opposite sign of what it is when it's in the circle equation. So your center x coordinate is going to be a positive 5. Your center y coordinate is going to be a negative 1. So right now my center is at 5, negative 1. Let's go through your choices. Now the first one, cross it off. It assumes that you think that the center is the same as what appears in the equation without having to change the signs, which is wrong. The other one that makes that assumption is D. So they're trying to trick you. They're trying to figure out, do you understand that the center is always the opposite sign of what's in the equation? So now we're down to choice B and C. Next, to get your radius, you're going to take the number on the right side of the equal sign, which is your r squared. So right now, r squared is 16. And you want to take the square root of whatever is there on the right-hand side. So if we square root r squared, the square and the square root cancel, so you get r equals, and then the square root of 16, which is exactly equal to 4. We're going to go with the positive square root. So 4 is my radius. That's choice C. So always, when you want to figure out the radius, grab whatever number is there on the right-hand side and square root it. Square root it. Not square it, square root it. Figure out what number times itself gives you that 16, or that number on the right-hand side. Now, if they asked you for diameter, well, if we have a circle and our radius is 4, our diameter would be 2 of these 4s back to back. So our diameter would be 8 if they asked us for the diameter, but they didn't. So your answer is choice C. Okay, let's keep going. Number 109. Read through the question and then come back. Okay. So in this question, they're talking to you about two different circles that are two different sizes and have two different centers. Now, all circles are similar, which is a really important thing for you to note. So we're going to take a couple of quick notes on this before we get started. So let's imagine this is our first circle, and then we have a second circle that's a different size. All circles are similar, which means one can turn into the other through a series of transformations. Now, for one circle to turn to the next circle, two different transformations have to happen for them to map on top of each other. The first one is a translation, which is a slide. What you want when you do your translation is you want the centers to map onto each other. So if this is circle A, and the other one is circle D, and we name circles by their center coordinate, what you want is you want the center of A to fall onto the center of D. So in this little visual, I would slide it to the right, and then I would slide it down a little bit so that the centers map onto each other. That's the first thing that you would want to do. The second thing that you want to do is you want to make sure they're the same size. So right now, if I mapped circle A onto circle D, it wouldn't be the correct size, but the two centers would be on top of each other. So it would kind of look like that. So smaller circle A inside of larger circle D. So when I dilate, I have to think about, well, what do I dilate by? What's my scale factor? So when you dilate, to figure out your scale factor, which we've done before, new over old, you're going to use the length of the radius. The new radius over the old radius. Let's take a look in our problem to see which of the two transformations they want to do first. Usually it's the translation, and then let's think about how we dilate. Okay, so circle A has a center at 3, -4. So I'm going to put that down, 3, -4. And circle D has a center at -9, 5. The radius of circle A is 2 inches. Okay, I'm going to put that in, 2 inches. And then the radius of circle D is 7 inches. Okay, 7. What sequence of transformations performed onto circle A to turn into circle D? Oh, I should have a couple of more words there. So what sequence of transformations performed on circle A will show that the circles are similar? It should say will show that the circles are similar. Okay, so basically A is going to turn into D, kind of like our visual showed. So the first thing we want to talk about is the translation. Notice all of your choices talk about the translation first. So you have to think about, how do I get from 3, -4 to -9, 5, which is a center of A to the center of D. Now, to get from 3 to -9, I'm clearly subtracting. You can even put this on a graph and count the boxes if you really wanted to make sure you didn't do this math wrong. But to get from 3 to -9, I'm subtracting 12. And then to get from -4 to 5, well, clearly I'm adding 9. So my rule should be x minus 12, y plus 9. So on a graph, I would move left 12 boxes and up 9 boxes. Let's take a look at which of our choices tells us that. Well, the first one adds 12 and 9. That's not it. The next one subtracts 12, adds 9. So I like choice B. Choice C, again, wrong movements. And choice D, okay, so we're down to choice B and choice D. Cross off A and C. Now it's going to talk about a dilation. One of them says you dilate 2/7. The other one says you dilate 7/2. Now let's think about our scale factor. Our scale factor is the new radius over the old radius. Since we're turning circle A into circle D, our new radius is the 7. So we should have 7 over our old radius of 2. So we're going to multiply by 7/2, which is about equal to 3.5. So it's going to grow 3.5 times larger. Of our two choices, choice D has the correct scale factor. Choice B uses the wrong scale factor. They did old over new. That's not what you want. So again, to recap, all circles are similar. You have to do 2 transformations to map one circle onto the other to show they're similar. First, you should do a translation. You want to get the center of one circle on top of the center of the other. 2, you want to dilate. Dilate so they become the same size. And the amount that you dilate is here. New radius over old radius. Okay, let's move on. Number 110. Find the measure of arc ABC. Okay, I'm going to highlight which part of the arc they're talking about. From A to B to C. Okay, one thing I should note is that all 3 of these arcs, AB, BC, and AC, are all congruent. And I know that all together, all of the arcs, the entire outline of the circle, equals 360. So if I divide 360 by 3, I'm going to get 120 degrees for each of the arcs. So I have 120 here, I have 120 here, I have 120 here. They want ABC, which is 2 of the 120s. So 120 plus 120 is equal to 240. That's the measure of arc ABC, 240 degrees. Pretty simple. Okay, let's move on. 111. Find the measure of arc AB. Okay, so they want from A to B, shortest route. Okay. Well, there's a couple of things in here in the diagram I have to pay attention to. Let me zoom in on it and let's talk. Okay, first thing that I notice is that they gave me a 20-degree angle for this angle right here at A. This is an inscribed angle. Its vertex is on the circle. Now, an inscribed angle and the arc that intercepts have a relationship. as you pull the 20 degrees forward to try and figure out the measure of this arc BC, you're going to double it. So again, as you take that angle and you pull it forward, notice it kind of grows and gets bigger. You're going to double it. You're going to multiply by 2. So 2 times 20 gives me 40 degrees for the measure of arc BC. That's the relationship between an inscribed angle and the arc. The angle is half the size of the arc. So as you pull the angle forward, you're going to double it. Okay, well, I still need to get arc AB. Right now, all I have is BC. But the other thing you should notice is that line segment AC passes through the center, meaning it's a diameter. So it's cutting your circle into 2 equal parts, meaning the arc from A to C is going to equal 180 degrees. And so will the other half of the circle from A to C. That will also equal 180 degrees. So to figure out AB, which is in yellow, what I could do is I could take the 180, which is what the 2 arcs AB and BC should add up to, and I'm going to subtract the 40 degrees that we just figured out by looking at that inscribed angle at A. I'm left with 140 degrees, which is the measure of arc AB. So my answer is 140 degrees. I had to know 2 things. I had to know the inscribed angle that got me the 40 degrees, and then I also had to realize that the diameter was cutting it into 2 halves, 180 degrees to the left, 180 degrees to the right. Okay, let's move on. Number 112, find the measure of angle 1. Okay, so I need to figure out this angle right here. Now notice that these angles that are in the center of my figure do not actually touch the center of my circle. I don't see a point for the center of my circle. So these angles that are in the interior of the circle are just floating around. What they're forming are vertical angles. Now there's a formula that lets you solve for the vertical angles here. At angle 1, it's going to be congruent to the angle below it. And then the angles to the left and the right are also going to be congruent because it's vertical angles, which we learned at the beginning of our school year. So how do I figure out angle 1? Well, I'm going to tell you right now, you're not going to get angle 1 at first. What you're going to get is one of the 2 blue angles on the left and the right. Now, the way that I like to think about this is if I shade in my vertical angles, and I'm going to shade in the one on the left and the right, the 2 boundaries to these vertical angles are going to be the arcs that you're going to use to figure out the blue measurements. So this arc is the boundary to the vertical angle on the left, and this arc is the boundary to the vertical angle on the right. Now the formula to figure out those vertical angles looks like this. Vertical angle equals arc 1 plus arc 2 divided by 2. So I have 2 arcs here, the 53 and the 41. Since I'm adding, it does not matter which one I call arc 1 and arc 2. But I'm going to add them together, divide by 2, and it's going to get me the measure of these angles right here, the blue ones. Okay, so vertical angles equal 53 plus 41 divided by 2. I'm going to grab my calculator. 53 plus 41 equals divided by 2 equals. Okay, 47. So the vertical angles that are the x's are 47 degrees. Okay, so if this is 47, let me fix that 7 a little bit. What I want to do is I want to find angle 1, which is the same as the angle up top and at the angle on the bottom. Now to do that, I hope you notice we have linear pairs here. So I'm going to grab one of these line segments, one of these chords. And I want you to notice that the 2 angles here are a linear pair. They form 180 degrees. So since I know x, to figure out angle 1, all I have to do is do 180 minus the 47 degrees and see what I'm left with for angle 1, which will be right here. So in my calculator, 180 minus 47 equals 133 degrees. That's going to be the measure of angle 1 up top, and same thing along the bottom. So key takeaway here. When you see that there are chords that are crossing on the interior of your circle, but they're not crossing at the center, forming central angles, you're going to use this formula. To get the vertical angles, you take the two arc boundaries, add them together, divide by 2, and that'll get you the vertical angles. And they both have the same measurement. All right, our final answer is 133, which did require one additional step, which is looking at that linear pair. Okay, let's keep it moving. Last question on this page. 113. Find the measure of angle 1. Okay, angle 1 is all the way out here. Now, when you see a circle and you see an angle on the outside, an exterior angle, there's a formula that goes along with finding the measure of an exterior angle to a circle, and it looks like this. Your exterior angle, which in this case is angle 1, is equal to the far arc, I'm going to use a little arc symbol, minus the near arc divided by 2. Now let's talk about what it means by far and near. I'm going to zoom in on this circle. Now, when you have the two sides that make up angle 1, I like to lightly shade in to see what parts of the circle's outline fall in between the two lines that make angle 1. So if I just lightly shade in here, my far arc and my near arc are going to be the ones that fall in this shaded boundary. So my far arc is the one further away from angle 1. Further away from angle 1 would be this arc right here. So I'm going to call that far arc. Far. The one that's closer to the external angle is this arc right here, which I will call the near arc. Now I'm going to do the far arc minus the near arc and divide by 2. The issue is I don't have the near arc. I have the 174 and the 119, but I don't have the near arc. So to figure out the near arc, we're going to think about, well, what does the entire circle add up to? And that's 360. I'm going to subtract the 119 and the 174 to see what do I have left over for that near arc measurement. Grab your calculator. 360 minus 119 minus 174. And you get 67 degrees. So now that we have our near arc, we can go ahead and use our formula. So far is 119 minus near 67 divided by 2. And that's going to give us our exterior angle. Go to your calculator. 119 minus 67 equals divided by 2. So your external angle equals 26 degrees. Now note, I use the words external, I used outside, I used exterior. Basically, it's whatever you see on the outside of your circle. You're going to do far minus near divided by 2. Now, you may get some problems where you have an angle on the outside, but you have a measurement for it. You can still use this formula and plug in for whatever you have to solve for whatever's missing. All right, so that completes page 22. Let's keep it moving.